All right, so let's go do this problem on the left-hand side. So let's look at 2x squared. So remember, f of x over here, this is f of x is just like saying y. So it's like having y. Uh-oh. Hang on a second. All right, give me a second. I gotta like reopen this. All right, so y equals 2x squared is simply like having a parabola and it's been stretched. So everything is going to be, every answer is going to be multiplied by 2. So if you have y equals x squared, you know, if you plug in 0, you get 0. All right. Used to be when you plugged in 1, like if you plug a 1 into here, you get 1. 1 squared is 1, but then you're multiplying it by 2. So this old point 1, 1 is now basically raised up to 1, 2. And then if you plugged in 2, you would normally get 4, like 2 squared is 4. But this 4 is now doubled, and so now it becomes 8. Right? So now that point right there, if I could do it, I would put it up here, like around 8. Okay? So this is my parabola. So sometimes you need to know the points of these things. So let's see. So it goes like this, up here, back here, same thing. Oopsie. Whoop. Over here, and back here. Oh, I'm sorry. This is here. I'm really messing this thing up. Remember, use some pencil. All right, and then -2 is there. So it's coming up like this. But this problem says I am only supposed to use this parabola when x is less than 1. So I go to the point when x is -1. So I go to -1 and I go to the point. So that's this guy right there. Okay, so I have to put an open circle because there's no equal bar. So I'm going to put an open circle there, and I'm only going to keep everything to the left of that point. So let me get my eraser. I'm going to erase all of this. I'm even going to erase that point because I'm going to put an open circle. Okay, so there we go. So draw the picture and then erase part of it. And this looks like a line, but you know, it is curvy. Like it is kind of curvy like a parabola. It's just pretty steep, so that's why it doesn't look curvy. Okay, so the next one. The next graph is y equals -1. So remember, y equals -1. Well, that's just a horizontal line. So y equals -1 is a horizontal line right here. Okay? And it's only supposed to exist between -1 and 4. So -1 is right here, 4 is over here on the right, and I'm going to erase it because I'm supposed to have an open circle. So I don't want everything to the left, I only want it between those two places. So I'm supposed to have an open circle because there's no equal bar there. All right, so let's keep going. The last thing I have to graph is a cubic function. All right, so normally a cubic function, let me just draw it to the side. Your cubic functions look like this. They come and they, snake up through the middle, kind of like that. So this thing has been moved to the right 3 and up 2. So right 3, up 2. So it's looking like that. So why don't we start plugging in some numbers? Because I know it's going to be kind of curvy like that, but let's just see what we get here. So if I plug in 4, 4 is the first number they want me to use. So plug in 4, 4 minus, whoopsie. Uh-oh. Didn't have my pen on. All right, if I plug in 4, 4 minus 5 is -1. -1 to the third is -1. And -1 plus 2 is 1. So 4 is 1. All right, let's plug in 5. So 5 minus 5 is 0. 0 to the third is 0. 0 plus 2 is 2. So 5, 2. Let's plug in 6. 6 minus 5 is 1. 1 cubed is 1. 1 plus 2 is 3. So 6 is 3. Now, this point right here in the middle, this one right there, that was the vertex. This graph over here on the right is moved to the right 5 and up 2. So 1, 2, 3, 4, 5, up 2. That was the center. So that point right there is the center of this cubic function, just so you know. It's going to curve around there. So it's going to kind of like curve over, and it's going to keep curving up like that. So basically what's happened is I have started this graph from like right about there and up. I'm taking that much of the graph. Okay, and there you have it, just by knowing some of the old pictures and applying them here. Like I said, I'll probably only give you like ones with 2 pieces. All right, so now we're going to get into this last little bit, and this last little bit is going to be a little bit weird, but you just have to kind of like use your mind and do what it says. We're going to be talking about if somebody asks you to graph the absolute value of a function, and this over here is f of the absolute value. They mean 2 different things. Okay, so first I'm going to draw a picture, and go ahead and copy it with me here. I'm going to try and give you some specific points, and we're going to draw the 2 pictures, the 2 things. So over here on the left, I'm going to give you a picture. It's just going to be a polynomial. It's going to go through -4, 0, going through -3, 2, goes through -2 right there, comes down and hits -2 there. So it comes up, goes down through here, kind of curvy. And on the other side, it goes through 2. It comes up to 3, 5, and goes down through 4. All right, so this is my picture. I just like randomly made this up. Okay, it's my quartic polynomial. It has 3 terms. It's x to the 4th. So there's my picture. So that's my original problem. So what I'm going to do with this original problem is I'm going to graph the absolute value of it. So what that means is that everything that was negative has to turn positive. So anything that's down here has to turn upwards. It has to turn positive. All the answers are now positive of everything that was originally there. So what I do know about this picture is that everything that was positive is going to stay the same. So this little space from -4 up to here, that's just going to be the same as it was before. Everything from 2 up to the 5, down to the 4, stays the same. That's all the same. But the other part is going to flip up. Everything on the bottom flips up to the top. So this little thing on the left-hand side, this guy over here, he's just going to turn upwards. It's just like you take him and you flip him up. This little part in the middle right there, he's going to flip up. So he's going to go to 2 instead of -2. Because his answers used to be negative, I have to turn them positive. And then after the 4, that thing's just going to turn up as well. So you can do this in Desmos if you have the equation. You can just type in absolute value bars around the function, and you can see what it looks like. All right. So for instance, if I show you that, if you're in Desmos and you want to do this, all right, if you have a problem and you want to know the absolute value of it, like let's say, let me just think of one right here. I don't know, like let's see, -x² plus 4. All right, so let's say I want the absolute value of this thing, and I'm going to go ahead and put like y equals in front because I like that. So all you got to do is take some absolute value bars, stick it around. I think you need the other one. You don't really need it. And there it is. So you see it turns it around for you. But that's if you know the equation. All right. So the next one is a little bit harder to think of. The next one is the function of the absolute value of the x's. So I'm going to draw a new picture over here. So new picture. And it's going to look similar to the old one. Let's see. Actually, I'm going to draw the same picture. I changed my mind. -4, that's 2, that's -2, right? Yeah. So same picture as before. Comes down through -2, up through 2, 5, 4. All right, so same picture. Now, this one is harder to think of. So what's happening in this problem, when you're doing the absolute value of the x's, every time you go to plug an x into this problem, like for right now, if I look here, like this point right here, when you plug in 3, the answer is 5. Right? When you plug in -3, the answer is 2, it looks like, right? Okay. Now, if you're doing the absolute value of x, every time you go to plug in an x, you make it a positive. So what's going to happen is the right side of your graph is not going to change. The right side is going to stay the same because when you plug in a positive, it's still positive. It's the same as before. So 0 is the same. When you plug in 2, you get the same answer as before. When you plug in 3, you get the same answer as before. So the whole right side of the graph doesn't change. But when you go and you try to plug in any of these negative values, what's going to happen is somebody's going to change them to a positive, and then what's going to happen is you're going to end up doing the same thing you did on the right side. So when you go to try to plug in -3 into the problem, and it used to be that you went -3 2, well now -3 is going to turn into a +3, and your answer is going to be 5 again. So -3 is 5. When you go to plug in -2, when you plug in -2, it used to be at 0 right there. Well, it's going to turn it into a +2, and it just so turns out that's the same answer over here. So it's going to, basically what's going to happen is all these points right there on the right side are going to get repeated on the left side. So do you see how the left side and the right side, they match? So basically what happens when you do the function of the absolute value of x, the left side disappears and it just copies the right side. Okay, so we're just going to do that in the next two problems that I have on the next page. Remember, absolute value means everything turns positive. This one means that the left side disappears and the left side turns into what the right side was. Okay, I know I'm going over a little bit. I'll just take like a couple more minutes. All right, so let's just graph our normal function, f of x. So a radical function square root moved right 2 and up 1. So normal square root function was at 0, 0, so now that's going to be right 2 and up 1 here. A normal square root, when you plug in a 1, you used to get 1, but that's going to be moved to the right as well. So let's go ahead and pick out some numbers. Let's plug in 3 here. So what's happening at 3? If I put a 3 right here, 3 minus 2 is 1, square root of 1 is 1, 1 plus 1 is 2. So 3 is 2. And then let's plug in like 6, because if I put a 6 right in here, 6 minus 2 is 4. I know the square root of 4 is 2. And so 2 plus 1 is 3. So, you know, with square roots, you want to be special about what you're picking. So there is the normal square root function. Or you can graph it on your calculator or Desmos or something too. Okay, so here I'm going to graph the absolute value. Okay, well, you might be thinking, what are you going to change? Nothing. I mean, literally, this whole graph right here was already positive. So if I tell you to graph the absolute value, there was nothing on the bottom. Like this whole area was blank. There was nothing negative. So the absolute value of this function is the same exact problem that it was before. It's still right here, here, and here, to there. Okay? But now when I try to do f absolute value of x, remember, oops, that's a line. Every time you go to plug in a negative, it acts like a positive. So the right side stays the same. The right side is still here. Before, we never had a left side to do. But now when I go to plug in -2, somebody changes it to a +2 because of the absolute value bars, and +2, the answer is 1. So -2 has an answer of 1 as well. When you go to plug in -3, somebody changes it to a +3, and then you get the answer of 2 like you did before. So what it does is it mirrors the right-hand side. So there wasn't a graph there before, but now there is because you have that absolute value inside there. And so if you wanted to type this into Desmos, you would type y equals square root. You would make this absolute value -2 plus 1, and you would get this picture. Okay, let's do this last one, letter B. So let's go ahead and make sure we know everything about this. This is your old rational function, 1 over x. It's moved to the left 2, and it's moved down 4. All right, so left 2. So my asymptote, my vertical asymptote is at -2. Move down 4, so there's my horizontal asymptote at y equals -4. Okay, so the function, if you were to graph it on your calculator, I just know what it looks like, but it comes through here, goes a little bit below 3, and comes over. And then it's over here along there. All right, so there's that problem. So this is my f of x. So now I'm going to do the absolute value. Oh my God. So that means that everything that was negative turns positive. Well, this part was already positive, so it's going to stay the same. So my graph, it looks like a little bit past 2, before -2, so that stays the same. All right. Now, the rest of it, this whole section right here, has to flip up. So it's going to flip up, and instead of approaching -4, it's going to approach +4. So it's going to flip up and approach +4. So it just flips over. All right. And then this whole section at the bottom, this guy right there, has to totally flip up. So he has to basically go right around here. So I know it looks strange. So we can go ahead and kind of change our asymptotes. This asymptote right here is still there, but the -4 changed to a +4. Okay, so that blue thing is the graph, but all right. So now for this last one. So in this last problem, remember I'm doing f of the absolute value of x. So what that means is the whole left side of my graph is going to be gone. All right, so I'm going to see if I can grab that and delete it. All right, good. I want these things gone. All right, there you go. So the whole left side of my graph, all I want to do is keep the positive side, because the right side is supposed to mirror the left side. So what I'm going to be doing is every time I try to plug in a negative number, it ends up looking like the positive side. So what ends up happening is the whole left side of my graph disappears, and the right side, which looked like from about here over there, gets copied on the left side. Okay? Because the left side, every time you try to plug in a negative number, it turns it into a positive number and just copies the right side. Okay, that was a little bit longer, but let's take a look at your homework. Why don't you let's see, bookwork. Why don't we say that you are going to section 1.5. Why don't you guys do the first 4 problems, 9, 13, 15, and 24. So just do those 4, and then we'll finish the rest in class next time. I'll see you there. Bye-bye.